Hey, Jeff.
Hey, Alan. Hello,
How you
everybody.
doing?
Welcome to episode 22 of Integrate Live. And Alan, today we're all about the speed.
Speed. Like that.
That's right.
Let's go
Remember,
fast.
do you remember the Keanu Reeves movie
Yes,
from?
I do. Love it. Actually, I think I just rewatched it on a plane not too long ago.
Oh, yeah?
Yeah, it
Um,
came up and it's like,
why
hey,
not?
I'm gonna watch that.
That's right. Did you know that that had no director?
I did not know that, no.
Yeah,
It
if there
kind
was
of
any
shows.
direction, if there was any
What?
direction, if there was any direction at all, they would have had to call it Velocity.
Another
Oh,
good movie, the first Star Wars. But did you know why Han Solo never enjoyed a steak?
Well, I do know this, Alan.
It was because it was chewy.
It was a little chewy.
oh my God.
You didn't tell me they'd be good, these jokes.
Yeah,
Well,
well,
usually
No,
they're
you
good.
know,
I don't know.
Sam, you know the difference between wallpaper and toilet paper?
Mm.
No.
That's gross.
I got one. I got one.
All right.
Horse walks into a bar,
Hmm.
sits down, orders a drink. Bartender says, "Hey, why the long face?" It's a
Yeah.
horse.
Of course.
No,
Yeah.
no,
The
I get it.
classic.
Yeah, we got it. Yeah. Yeah.
Skeleton beside him orders a beer and a mop.
Exactly. Skeleton. Got no guts.
Mushroom
Oh,
orders a drink.
so
Bartender says no. And Mushroom says, "Why? Because you're not a fun guy?"
Oh
yeah.
my
Sorry, Alan.
So I went to Starbucks yesterday.
God.
I went to Starbucks and I asked them for their mildest roast. And the barista looked at me and said, your ears are very average.
That's good. That's good. That's good.
Everybody's been talking about Elon terraforming Mars lately, but everyone I've talked to is they're not really into the whole going out there when it's ready. They're worried it's going to be too musky.
Yeah. Yeah.
Oh.
Well done.
Good one. Really good one.
You know
All
why
right.
dinosaurs didn't make good pets?
No, I don't know why.
Because they're all dead.
Welcome to the audience. Welcome to our panelists. Let's get a round of introductions going here. Alan, first. Hey, we've got over 260 registrants on this one. So that tells me that we've got some first timers. So let's just start off. Alan, say hi to the Integrate Live audience today. Tell them just two quick things about yourself.
Two quick things about me. So let's see. My name is Alan Ray. I am the OT security director for 3M, and my joy is in the Integrate Live community and building out the opportunity to collaborate and really see problems that we all deal with in all industry, especially in control and automation. See those problems be solved by solutions where integrators are working together and contributing to make sure that the solution is effective and costly and can be deployed easily.
Awesome. I've had the joy of knowing Alan now for it was before COVID. That's how I mark things.
Yeah.
So at least 6 years. And he's a good friend and a good partner. And some would call you wise. I
Uh,
I'm not there yet, but some do call you wise. Everybody, hi, my name's Jeff Nepper.
I just have a question. Is there a second word after that?
No, there's not, just
Okay.
wise.
All right. Okay.
Just wise. Everybody, hi, my name is Jeff Nepper, and I'm a father, I'm a husband, and I am passionate about helping solve problems and getting to know people. Probably super high relational and curious. Best ways to describe me. Thanks everybody for being here. We've got some panelists to introduce. I'm gonna go, let's go round robin. Let's start with Logan. Logan, you walked up to me in Folsom at the Inductive Automation show 2 years ago and said, "Hey, I've heard about your team. I want to know more." And it's been an awesome friendship since. Tell us a little bit about yourself. We'll do the outside
Absolutely.
thing later. Just tell us about you.
Sounds good. Yeah. So my name is Logan Terry. I'm the operational director at LSI. I'm also a father and a husband and an engineer by degree, mechanical engineer by degree, actually. Started out my early career oil and gas focused. I grew up in southern Alberta. Everything is driven by oil and gas around there. Shortly after university, oil took a downturn, switched gears pretty heavily into industrial automation, primarily in food and beverage and pharmaceutical. And it was one of the best pivots I've ever done in my life because it introduced me to the career now that I am extremely passionate about, which is how do we use technology to solve complex manufacturing challenges and ultimately make people's lives easier day to day. So that's a little bit about me personally.
Well, thanks for being here and looking forward to seeing you again at a conference in a couple of weeks. We'll talk more about
Yes,
that
sir.
in a little bit. It could be a virtual background, but I actually have word that it's not. Sam over at Kepware, yeah, like
Yeah.
you're hands off to our friend Kyle for apparently setting up
Yeah.
a beautiful little studio for you.
I think he's on too. Kyle, thank you from the bottom of my heart for jumping in. This is a wonderful studio you've put together. Yeah, so Kepware's been part of PTC for a long time now, and it comes with some nice digs. So anyway, nice to meet everybody. I think I see some of my great colleagues in the attendee, Craig Egan, other folks. It's just been a pleasure being able to spend my career working with all of you. And for those I haven't been able to work with yet, you just wait. I'll get you someday. First off, my name is Sam Elsner. I direct our solutions consultants for the Kepware business within PTC. I happen to have the privilege of starting the team back in 2013, and I've built out the team to about 7 people spread across the globe now. Our roles have changed, a little over time, but for the most part, we're the de facto sales engineering squad for Kepware across all of the end users, partners, internal folks who need to understand how Kepware works. We'll support marketing efforts, we'll support post-sales efforts, R&D efforts. So we get to wear a lot of hats. But primarily, we are a bunch of people who love complex systems and we love helping people. And so combining together, we love helping people understand complex systems. And we're able to work on the Kepware product or represent or use the Kepware product to solve a lot of different types of problems in the automation space. So I was lucky enough to find Kepware, little company in Maine, maybe 30 people back in 2011. We were experiencing some growth. We continued to grow really, really significantly until we were purchased by PTC in 2016. And my team and I continued through the acquisition. We've added staff, and I think we've tripled the Kepware overall annual run rate of our business since PTC acquired us. So it's been a good set of years since the heydays of private company Kepware before we were part of a public company. And what I say is really happy to be here. It works really well having a huge PTC behind us, being able to get us into different markets and get us into different types of conversations that we really didn't before. But anyway, enough about that. About me, I'm a father. I am a husband. I'm a son. I'm a friend. I like to spend my time primarily these days with my kids. They're 6 and 3, so they're busy and demanding, and it's a wild time. But most of my hobbies either revolve around them or industrial automation stuff. Automation in general is fascinating to me. I started early on developing web pages and different apps as a kid, 10, 11 years old, building computers. Had a kind of early midlife crisis when I went into college and decided to study liberal arts. So I have a liberal arts degree in anthropology and a minor in business finance. But throughout my entire time in university, I worked at in IT positions, whether it was a media design company on campus, building out multimedia systems for fundraising, or if it was for the museum on campus, I was the IT guy and the web administrator. Always keeping my toes in technology. And then when I got out, I found data storage and backup systems for a number of years, 4 or 5 years I spent doing that. Heard about a new thing called Azure in 2006, 2007, and had no idea that I would be sending just an incredible amount of data to it come 2024. But my career spanned, the humanities to sales and marketing to engineering and technical design, and now sales engineering and customer support is what I focus on. So really good to meet everybody. I hope to be able to work with all the folks who are attending on something, whether it's a small little piece around Kepware or just catching up with you at a conference sometime. I love this stuff, and it's a pleasure to be here, Jeff. Thank you for having me and Kepware and PTC aboard.
Yeah, well, Kepware has been a huge supporter of Integrate Live since its very beginning. Super grateful for all of the men and women within Kepware and PTC. Two cool things I learned about Sam in this interaction. I learned that Sam can jumpstart my house with his new EV truck, and I learned that Sam is my mentor for all things science fiction. He is an avid science fiction reader. So if you've got a great sci-fi book you want to recommend to Sam, drop it in the chat. Jacob, I'm coming to you next. Preparation. And to the audience, we're going to take questions, not out of the chat. All right. So I just want to clearly state, please don't put questions in the chat. I'm not going to monitor it. I will monitor your questions in the Q&A. So if you have a question, Q&A. If you want to just cut up, have fun, tell jokes, chat. Also, Sam, at the very end of today's project, everyone that hangs on to the end, you're going to tell them how Kepware got its name. Fair enough?
Yeah,
I
sounds
guarantee
good.
no one knows if they don't work at Kepware, and half the people at Kepware probably don't know. Jacob,
Yeah.
you win the prize for the brain I am most interested in dissecting based on your office space. I'm still trying to figure out the layers and the levels and what this came about. Tell us about yourself. Tell us about how you got into engineering and how on earth you got into automation.
Yeah, so I'm a mechanical engineer, much like Logan. Story I always tell is in my capstone course for mechanical engineering, we did a really complex mechanical design, and afterwards I went up to my professor and I asked, "How do we make it move?" And he said, "Oh no, electrical engineers do that, controls engineers do that. We don't do that." And that was the day that I got started in automation. That was not the answer I wanted. So started as a controls engineer out of college, moved into R&D product dev, and then got into SCADA, MES, started doing some AI stuff, got into a bunch of cloud, ultimately circled back to system integrator Flexware, where I'm at now. And I think as far as the one thing to know about me, I live and breathe this community. I am diehard IIoT. I love this industry so much, and I love the people that we work with. And like everybody else on this call, I'm really passionate about helping the community and helping people and customers with these challenges.
Awesome. We had a comment. Please, can we just start? So sorry. Join 15 minutes late. Always on workshops. If you don't want to know the people or hear jokes, join 15 minutes late. And otherwise, I'm sorry, it's just not the thing for you. It's just the way we do it. Apology. Well, you know what? I'm not even sorry. All right. So Jacob, you are over at Flexware. Is that right?
Yes.
How'd you find Flexware? Tell us about Flexware a little bit. Actually, you know what? I've got a slide for this. One second. You start talking about
Nice.
Flexware. Bring up a slide for you that Dwayne sent over for us.
Yeah, it's kind of funny. People at Flexware, especially the recruiters, I know this. We've been in contact for like the last 5 years, and it just hasn't worked out. Multiple interviews, and ultimately, it all clicked and came together, and I couldn't be happier. So, yeah, Flexware is a system integrator out of Indianapolis, Indiana. We've got capabilities through the entirety of the ISA 95 stack, all the way from layer 0 all the way up through cloud. We work in pretty much every industry vertical: pharma, food, automotive, metals, utilities, energy. And I think we're looking to expand even more. Just recently got acquired by Hitachi. And yeah, I can't speak highly enough about the people I work with. Just a big community of nerds, basically. Just we all love what we do, and outside of work, we have really good camaraderie as well. So um, super happy to be where I'm at, and really love Flexware. So yep.
Well, it's great leadership, great people. I've always been impressed with everyone we've run into. And it was awesome to hear on the Hitachi acquisition. That was a really incredible move to scale the company even beyond, I'm sure, where Scott and the team even ever thought it would go. Let's, Logan, you've been at LSI not long, but tell us a little bit about LSI. Your integration experience, I know, goes back a decade plus, but what caused you to go over to LSI, and what is LSI all about?
Yeah, definitely. So, when I started, looking for a new career home for myself, there was a bunch of things on the top of my list that, I was looking for in a company. But the top three were culture, capability, and coverage. So one, the culture at LSI has been absolutely fantastic. The leadership really fosters growth, innovation, entrepreneurship. So if you have a good idea, bring it forward, and they're going to turn it into a reality or help turn it into a reality. Capability, I've been with LSI for just about 3 months now only, but the capability with this group is incredible. When they say full coverage services, they really mean it. Like all of the major DCS platforms, all of the SCADA, all the HMI, all the hardware platforms that you could ever find on the plant floor, we have an SME in-house that can help you with it. So, but beyond that, capability goes just, outside of the traditional controls and automation into EPC and process engineering, electrical engineering, panel fabrication, the whole coverage. So kind of like to joke that, if you have a project, if you have four walls and a pad, and you have an ERP deployed, we can help with anything in between. So really full life cycle coverage on the services. And this slide just kind of gives a high level overview of where we're located. So really, really good coverage across North America, a couple offices, one satellite office, one brick and mortar in Canada, a bunch of others in the US and some internationally as well. This last systems integrator giants list, I think we were number 13, 100 plus million year annually projects executed, and 10 offices and 350 employees worldwide. So it's definitely it's a big player in the controls and automation space, and I'm really, really happy with the decision to come on board here. It's been nothing but fantastic.
Awesome. Well, thank you for carving off time to be with us today. And for everyone, I think we're ready to kick it off. Sam, we're going to ask today that you do some demos for us. Obviously, we're going to hit some of the Kepware pieces as we go through. But to the audience, Sam, I'm going to come right back to you real quick. Let's walk through, if you would, on the Kepware side. Obviously, I think a lot of us, actually, it'd be great on the chat. Is there anybody in the audience right now who hasn't had experience with Kepware yet? Maybe just for the first time, you've been using other OPC servers, or you're seeing Kepware maybe for the first time today. If you are, just shout it out. My assumption is that most everybody is familiar with Kepware. What are a few things, though, that you would frame up to them that they may not know?
Yeah, sure. So we certainly have a history of acting as a DDE or OPC server, OPC DA, OPC UA, but between say 2013 and 2016, we began to realize that we were creating a communications platform. So as much as Kepware has been used by HMI panel vendors to provide a driver so that their HMI software can talk to a few dozen PLCs, Kepware also is an enterprise platform where it has the capability of managing or coordinating messaging flow throughout the organization regarding industrial automation, really where data comes from and where it needs to go. At the same time as we're still facilitating this classic operations technology use cases like HMI and SCADA. So we began to add different types of interfaces into the Kepware platform. We started in 95 as a DDE server. We joined the OPC Foundation, added an OPC DA server, added over time an SNMP agent to Kepware. We then added an OPC UA server, a database outputs. We have now MQTT publishing and consumption, HTTP publishing, light HTTP consumption as well. We have REST APIs where you can read and write values and browse just like an OPC experience. So we're really this heterogeneous message coordination and a sort of digital transformation platform. As much as we still can scale down really small and live behind the scenes of an HMI panel if you wanted us to, we can also grow very large, have multiple nodes associated with running your Kepware instance, and you could be putting all of your messaging flow through Kepware. So we have a long history of doing this. We've been working in the automation space, as I mentioned, since the mid-90s, early vendor as part of the OPC Foundation. And then what happened in 2015 and 2016, many different companies came knocking at our door and said, hey, data is the future. So please, can we get some of you? So over time, we continued to evaluate different offers, different types of trajectories for Kepware. But long story short, we became part of PTC in 2016, and we've been continually invested in as an important part of the digital thread strategy is PTC. But also, we operate our own kind of segment and continue to sell the Kepware platform to really anybody and everybody who might need industrial communications management utilities. We've been getting into unified namespace deployments. As I mentioned, we've had MQTT publishing for 10 years. Now, it isn't just to cloud-hosted brokers or small brokers, but really intentional brokers as data organization platforms. We've also been doing a lot of publishing to time series database platforms, large learning models. Really, the sky's the limit in terms of the systems that can consume data from Kepware, especially now that we have all of these web service chops and have had those chops for almost as long as we've been an OPC server at this point. So immense
I can give some
background,
examples real quick.
expertise.
I can just give some
sure.
examples of where
Please.
Kepware has made a huge impact on the end user via the, when I was at Air Energy and, you run into problems like we had Wonderware that at the time using Universal Stack Server, it handled all our polling for all our serial radios, and then transitioning to Ignition, we could not use Universal Stack Server anymore. And so we tried to build the polling system in Ignition and we could get it to work, but ultimately Kepware out of the box made a polling engine that just worked. And so it solved our problem quickly and gave us the robustness that we needed. The other things that you start to think about is, even if you're using Ignition and you need, let's say you need ASCII values out of an old PLC 5 or 500, you can't do that through Ignition. You got to go through Kepware. So a lot of these unique situations where you find yourself with this barrier because of legacy equipment, legacy drivers, all these different things, that's where Kepware just literally shines for the end user. And then a lot of the problems that I've noticed is that Kepware does so much, but we tend as an industry to get so tunnel visioned on the things that we're dealing with, and we stop looking at what else could we do, right? And Ignition has had a big impact on me on this because the whole mindset of think it, do it, dream it, do it, right? So then it's like, okay, well, these are tools that we have. They're in our toolbox. What else could we do with them? And Kepware to me is like Excel, right? It's literally I can get into Excel. I can learn how to do some formulas. I can do some cool stuff. And then when you meet somebody who
Actually
really uses Excel, you're like, oh, I had no idea, right? So Kepware for me has been the same kind of thing. Is like, man, you want to find yourself in a place where you're like, I've got a problem. It has to do with data. Like, what tools do I have in my toolbox, and can the tool already solve the problem instead of spending hours in development trying to program your way out of a problem? Often Kepware already has it, and all you got to do is just call them up, talk to somebody, get those contacts, and and you can save yourself so much time and headache and energy because it's already there and it's already tested, vetted. You don't have custom code. You don't have to worry about, hey, when I do an upgrade, is it going to break? All those things are just work.
Alan, you brought us right into our business use case without knowing it. So to the audience, Alan's had a super busy schedule, something about his job at 3M and his integration and his grandfather and his father and his husbandry.
Yeah, well, all that stuff.
But the beauty is that Alan, the use case today that you're going to see us walk through is literally how to take the system you already have and find efficiencies and savings that have just been living in the margins because you haven't actually engineered the system to its full potential. So what you just described is, hey, someone who's putting Kepware in or has already had Kepware for 10 years, Sam's going to walk us through, and Logan and Jacob are going to share their experiences on things that you can think about and do and change to get better resolution, to get higher performance, to get quicker throughput, and literally start saving yourself time, right? Because higher efficiency, better safety, better quality means more, better margins, better profit, more time, less cost. So that's our use case today. And to kick it off, um, before we talk through it, let's just hit the super basic architecture, okay? So for the audience, now I just got to figure out where my Zoom window went and bring it back up. Sorry, everybody. To the audience, what we're really looking at today is we are going to identify, with the help of the team, between all of the different integrations from machine to PLC, PLC to the OPC server to your database, database to your app, and then back down the chain, back to the control side. We're going to walk through different efficiencies, different ideas for tuning, different ideas for how you should be engineering these solutions so that you can get the most out of your investment. So to kick us off, let's start off with that concept of just on the PLC side, connectivity down to the device, to the sensor, to the machine. And we'll just open it up to the panel, whoever wants to go first and jump off. When we're talking about that side of the project, what are you focused on?
Yeah, I'll jump in. I
Please,
think
yeah, go ahead.
in the grand scheme of talking about bottlenecks, right? If we want to eliminate bottlenecks, I think our focus probably will shift elsewhere after we get to the higher levels of this architecture. At this level, when you're talking, PLC or RTU to, sensor or machine, you're typically talking, electrical hardwired signals where it's, digital or analog signals where response times are extremely fast, right? PLCs are built for speed. Safety demands it, operation demands it. So you're talking, microsecond scan times, right? And these signals update extremely quickly. So that when we're talking about that time frame, that's likely not going to be the bottleneck in the grand scheme of high speed data acquisition or retention. So, but there are situations where PLC is connected to another machine and it's not a hardwired signal, it's some form of communications, right? And there's certainly considerations and limitations depending on the legacy of equipment. If you have PLC talking over remote IO to another piece of equipment, or that's a bad example because remote IO is pretty quick, but say DH plus and you have node messaging happening, right? There's some inherent latency there compared to more modern day protocols. As you start to move up and you start to leverage things like TCP communications, SIP communications, that latency starts to drop and you start to get closer to real-time communications. But in the grand scheme of things, I think the rest of the conversation will likely focus on the higher three levels of this architecture.
Sam, in your experience,
Yeah.
I imagine you're constantly taking calls and acting as a advisor. What are some of the things that you wished the programmer would have thought through when they were writing the code for the PLC that later on you're like, oh man, they really could have done this better?
Yeah. So a lot of the times what IT or software-based operations would communicate with are gateway devices down to subnetworks. So we're talking maybe an Ethernet connected device, and then maybe an Ethernet connected device down below, or potentially hardwired signals, or potentially serial-based networking. And there isn't a lot. Well, oftentimes the intentionality of data access is not part of the design or the functional requirement document that the controls engineer might be following. So when they choose hardware modules for their device, when they integrate multiple, say, remote IO modules, they may not know about the interface protocol that's used with the device and how that function call that we're making might actually require that middleware device to go out across the subnetwork and begin to query its downstream system. So that can put additional load onto the subnetworks that can cause performance delays. This is just to say intentionality or purposeful design of data collection during the programming phases is incredible. And this looks and feels different depending on the type of architecture, type of system you're programming. It might be that you, as a programmer, are using an older device, and so you need to make sure when you're building out your variables, they occupy
that awkward moment where you wonder if Sam's going to come back in fast forward mode or just drop off completely. And the panic that Kyle's feeling right now on his side.
registers or all of the systems into a single request and have that delivered back to us.
Sam, you hung up for about 20 seconds.
Did I? Oh no.
But that's okay. A question came in.
Sure.
OPC-UA over proprietary protocols like Siemens S7, Allen Bradley, etc.
Sure.
PLC programmers have tried, and I'm sorry, not the technical guy here, but is it SIMIT or SIMIT? I don't know if how you.
I'm not familiar with SIMIT.
Okay, but a little to have to implement.
Yeah. So it's all about the implementation of the protocol, whether you're Siemens and it's a proprietary protocol, or if you're Siemens and it is your standard like OPC. Right now, the OPC stacks that a lot of vendors are putting onto devices are much more resource constrained than, say, Kepware on a general purpose operating system on Windows. So we could do hundreds of thousands of data points at very fast intervals, both directions out of Kepware as an OPC UA client and server. But to ask the same thing of a PLC would be incorrect. So when we really look at OPC UA versus proprietary protocols, the UA systems, embedded UA systems, are just not as performant right now. The vendors are putting a lot of time into native interfaces for devices for programming purposes and for their own proprietary data acquisition systems. And here you have Kepware and a few other third parties who decide to build protocol drivers, sometimes with vendor support, sometimes without vendor support, to take advantage of those native or proprietary interfaces. And what I'll say is that usually the intention of the vendor or the attention of the vendor goes to the proprietary interfaces today over the more open standards. So can you read 10,000 variables at 100 milliseconds over UA from a Siemens S7 1500? Well, you might be pushing the boundaries a bit. But to do the same thing over the proprietary, register-based or symbol-based protocol from Siemens might be much more reasonable. So from our customers that we talk to, they'll use both. They'll use some, OPC integrations directly, whether it's from Kepware, directly from a collection system, for infrequently changing data from a PLC. They'll use really heavy OPC with general purpose operating system support. So this would be like, time-based, certain historians have OPC interfaces that are really high throughput, both on ingest and reverse. But again, to ask a resource-constrained embedded operating system running potentially on VxWorks to do it at the same time that it's supposed to be doing ladder logic and computation and supporting its native interfaces, I think OPC UA's name kind of gets dragged through the mud a little bit when really it's more about, yeah, they might have bitten off a huge amount of stuff marketed maybe to, a lot of different kinds of things. But when it comes down to it, the UA standard is very performant, but when it's implemented on resource constrained devices, it's not. So, or it hasn't been. So care should be taken based on the use case. So some customers who have enormous volume and veracity and speed, they'll use native. And at the same time, that another system will come in and collect over UA lightly. But again, that's changing over time. Operating systems on devices, resources available to PLCs are getting are getting more and more. PLCs themselves might be running Linux with real-time patch instead of VxWorks, where it opens up, maybe it has a quad core processor, 2 quad core processors associated with it. So, the architecture, the hardware is changing, the implementations are getting better. And so UA versus a lot of other stuff, I think, is a changing animal right now. You could say the same thing about MQTT. The systems that build MQTT into the device stack, because of the serialization into plain text, is just going to be inherently slower. By the same comparison to a native protocol over something like a packed binary message. So anyway, programming languages, all kinds of really interesting questions in there, that they could pick up. But maybe I'll stop there. Hopefully that was a useful. Too much rambling.
No, you're fine. Yeah, so I think just Jim, OT world, Windows is still supreme. As far as I can just tell you from a vendor perspective, it's what I've always run into the most. But Linux is quickly gaining ground. Specifically as IT has had more say over what's getting installed at the plant, right? They don't want to
I
manage.
love our OT customers. I say, we're building Windows stuff because you guys are using Windows. You
Right.
folks are using Windows, and they'll reflect back and they're like, we're only using Windows because you're building Windows
stuff.
That's well, yeah. So there's a bigger complexity here too, because if you think about the maintenance and support of your systems, right? So if you have a large Windows base and you have all the tools that you can support, you can manage and patch all those things. You have all those embedded tools for Microsoft. You need a completely different team and skill set and tool set to be able to do Linux. And so, like when I was at Era, they were like, "No, we are not going to support Linux." Not because they didn't want Linux from an IT side, but because they couldn't get the resources and they didn't have the capacity to be able to support it, which at the end of the day causes a lot of loss of opportunity because you just have that hard line that says no, we're not going to do it. So yeah, it's complex, it's hard.
Yeah.
What's been really cool is seeing containers arrive onto the scene. We've in the IT side of our business, we had a container in 2019 and 2018, but it's only been recently that we've had real run rate and real interest of OT sides automatically deploying containers and managing them through Kubernetes. And again, it depends on the kind of customer, the maturity of their own technology stack, and a whole lot of other factors. Like, is this actually going to make my company more money doing this? But in a lot of cases, it does, and it is, and it's been another angle of getting sort of alternative to Windows operating systems more present in our space.
Yeah.
Yeah, and do you have the skill set to be able to?
Oh,
I mean, one thing, not just okay, I'm going to take some IT stuff and put it up in the cloud, but do you have the skill set to actually do it securely? And do you have you have the standards and the kind of the guardrails in place to make sure that whatever you're doing there, you're protecting your company and the data and all those things. That becomes very complicated too.
I'm going to bring us back in, guys. Let's just come back real quick to our architecture. Any final thoughts before we start talking about identifying bottlenecks and ensuring between the OPC?
I was going to say something really briefly, like super quick comment.
Yeah.
The mission of high speed throughput in terms of data acquisition is converting all the binary onto TCP/IP essentially, because all of your upstream, protocol is going to be over Ethernet IP. And, binary protocol is super important at the layer 0, 1 for high speed. And that's why Kepware, I think, is so important, because it represents a place where you can connect on to TCP/IP, which at that point, then you have a lot more flexibility with what you do from there. But yeah, just wanted to reiterate that.
Yep. Yeah, thanks for adding that, Jacob. It's an important part. And you can kind of have your choice of TCP flavors too. We could even get access to data using UDP in some cases. So very much a physical network bridge as much as it is a protocol of, layer 7 protocol converter.
And Kyle called out in the chat, allotting at least 10% of the PLC memory to reserve for comms, if not built in already.
Very,
Yeah, so
very
some
important.
like Logix devices and
Couldn't
others,
agree
yeah, you
more.
can have a time slice. And Siemens does this a little bit differently. Other systems don't do it at all, and you can actually see the ladder slow down as you slam it with communications. But I think it's a good lesson that these are not data servers. Their primary job is not data servers. But everybody, I live in an area where we treat them as data servers. You know, and a lot of the interfaces that we're using on these devices, even still today, are programming interfaces. They're primarily programming. So it ends up being a challenge. I love it. I personally can't get enough of this tuning and difficulty, but it's a real challenge to do well and do right. So yeah, I'm glad we're talking about this today.
Yeah.
Maybe
And
one other thing, sorry, Jeff, to add there is, and Sam, you may have, I think you were maybe starting to mention this before we lost your audio for a sec there, but there are limitations with any protocol and with any communications medium, right? You run up against the laws of physics, and once you get to there, you're doing pretty good. But if you're running into that problem, there's different approaches that you can take to start to resolve this. So, if you're talking really, really high speed data acquisition, sub 50 milliseconds, maybe into the, sub 10 milliseconds, I don't know if there's any systems, data acquisition systems that are going to allow you to pull that information that quickly. But then you can start to use concepts in the PLC, structure your code better. You can start to buffer within PLC arrays. So you can say, every scan, I'm going to save a data point and a timestamp in array, and I'm going to save, 50 milliseconds of that. So my next pull will pick up that entire array. So if you're doing a study or analytics on, the motion curve of a really high speed motion application, you're not going to pick up 1,000 measurements per cycle, right? With a common pull response architecture. But if you buffer that, you can see that whole curve very, very detailed once you transmit that array up to your higher level system. So
Yeah,
some
and
other
to
concepts.
that point, for buffering, I find that batch operations are way more performant than on-change operations. So
Yeah.
if you're buffering and you're doing the scan cycle for on-change to buffer into an array, if your upstream process batch transfers that, it's a lot more performant for that single operation. So that's always something to keep in mind there too.
Absolutely.
Yeah, you're respecting the fact that you have a real-time operating system at your disposal in a PLC. So a lot of our customers might use an extra device just as a data aggregation point, just to be able to have a flexible, real-time, high-speed, programming surface to capture this, as you mentioned, Logan, stuff it into an array, stuff it into user-defined tags or structures, and then we can comb that at normal say real-time speed for us might be 100 milliseconds, 250 milliseconds, not sub-millisecond like a real-time OS. So huge benefits and huge savings there. And instead of forcing the middleware application, the communication platform like Kepware, to constantly interrogate the device to see if the data is ready or data is there, why not just have the device push it to us using a variety of different mediums and protocols? And then we'll actually get into that during our demonstration today.
Okay. So just kind of some takeaways, things I heard. You can't have it all. Make a plan, prioritize, and really diversify, right? So I heard, hey, if you want easy, fast plug and play interoperability, great, there's protocols for that. If you want to engineer something for high speed, high performance, then you might want to look at native integrations with that piece of hardware. I heard you talk about how fast do I want to process or analyze this data? So is it more important that I just have the high resolution? And so I'm batching a series of values into an array, and then I'm moving them after a delay. Now I've lost a little bit of that immediacy, but I can get a higher frequency of data. I'm just going to get at it a little later. Or do I want on change and lower frequencies? Question came in. When you talk about high speed, what is your requirement for firewall bandwidth? 10 gigabytes or more?
Just depends on how much data you're transmitting. And, as long as there's bandwidth, your latency shouldn't drop. So, if there's, if you need to move 1,000 pieces of data and you've calculated that each one is a, 20 byte message, then geez, a 1 gig network is more than enough. But Well, maybe I'll leave it at that and see if Jacob and Logan have any more applied thoughts about it.
I definitely have a comment there. So you're definitely going to run into networking issues, but in my experience, it's hardly ever a bandwidth issue. It's more about traceability and observability into the network, as well as ACLs, VLANing, segmentation, etc. So you're going to run into a lot of roadblocks in networking, but in my experience, it's not usually bandwidth. Most IT infrastructures, have 10 gig speeds. You can go even beyond that at this point with certain hardware. So that's my experience in networking with these types of issues.
Yeah, a lot of the networking that we'll end up doing, at least the Kepware product itself is as a cost profile and a size profile that allows us to have many individual deployments in a plant. And so when we think about networking to 2 or 3 different PLCs in a work cell, we may only have a 10-100 network to those, but it's absolutely fine. The volume of information is small, so our latency is not dropping, but you get higher up the stack, and that's where additional systems, you'll have more context. So the actual to transfer a value from PLC to Kepware using a data protocol might be 4 bytes. To transfer that same value, but with a metadata wrapper around it, because you wanted it in JSON and MQTT or OPC or database output, it's going to be a lot bigger, 100 bytes potentially. So it just depends on the interface protocol, how much bandwidth you need from that middleware upward or communications platform, enterprise standardized data collection layer upward. The bandwidth requirements do get bigger.
Yeah, that's a really great point, Tam. And something I'll add to that is, you mentioned it earlier, you get away from the pull response architecture into a more event-driven publish subscribe architecture, and even then into report by exception, where every decision that you make at that level, depending on, where the data's got to go, if you're talking through a firewall, it's probably going to your IT network somewhere, maybe to the cloud. So, network bandwidth is a concern, but also the ingestion cost for that into the cloud is a concern as well. So everything you can do to reduce that the packet size per message, right, is going to be important, and reduce the overall packets per second is important as well. So going with report by exception, going with pub sub modeling can drastically reduce the unnecessary traffic that goes through your network as well.
Yeah, it's such a good point. Bandwidth represents cost in infrastructure and especially in cloud. And a lot of people don't really consider that. And I've ran into that many times is where, we were getting the data we need, but it costed, 10 times, 20 times the order of magnitude. So that we expected at that point. So, these considerations for high throughput aid in the throughput you can get, but they also lean out the cost of the transfer as well. So that's definitely an important consideration.
It's where we see the ideas of distributed architectures, right? If it's should I be processing this data closer to source instead of bringing it across a network? And depending on your industry, this is something that you may never be challenged with. But if you're in oil and gas, if you're in distributed assets, this is a constant balancing act you have to do. Which just kind of brings this whole conversation full circle to say, I guess you kind of have to do your best up front to engineer the solution you think you are needing, while also building in resources for future proofing. But at the end of the day, there is no getting it just perfect, right, or nailed down at the beginning, right? Like, it's the continuous process is what it sounds like.
Absolutely. Yeah. So, choose tools that give you that, hopefully you can, be, put your research hat on. If you don't have tools, you could figure out which tools to add or which parts of the platforms that you're currently using might benefit from additional expertise.
That's right. Alan, in my garage, everything's a hammer, except for the screwdrivers. Those are chisels.
Yeah, so it's a good point because, the differences in my shop, like if I ever have an opportunity to buy a tool because I have some little niche thing, I do it, right? Because I want every tool I have or every job I do, I want to be able to do it effectively and quick, right? So I spent more money on my table saw fence than I spent on my table saw, right? Double the amount of money on my fence than I did my table saw. Table saw does one thing, turns a blade. That fence, I have to be accurate down to this 30 seconds or the 64th of an inch. And so, same thing when you're dealing with control systems, you start to, because the problem is if you come into a system, take a legacy oil and gas system, and now I've got a bunch of serial communication, right? How do I take a well that's out there in the middle of nowhere that has a 900 megahertz, 115 baud rate, and get that data to my system so that I can get, what is my per stroke, you know, pressure and temperature, and what's that card showing from my well site? How do I get that? And so, and what we've done is, to your point, Jeff, we've made everything into a hammer and a chisel, right? We said, okay, fine, I've got this. I'm just gonna dump a bunch of data, or you say, only give me this one data point. That's all I can take. I can't have anything else because of the legacy. Instead of actually starting to look at what's my opportunity with pub sub? Can I put in a piece of equipment that will convert to pub sub, and now I can push it over, Ethernet, and it gets complicated because now you got protocols, you got wrappers, you got all those things, but that's where Kepware comes in and will help you.
Yeah.
And so Kepware is that tool that is the fence, right? It's you can get the precision you want with the right tool set, as long as you're configuring it in a manner that is acceptable to what your bandwidth is.
And Sam, is there anything on the Kepware product side, if I'm looking at Kepware for my solution, is there something I need to be considering when I'm trying to pick the right license within Kepware? Or is it, do I just grab Kep Server EX or I guess,
No, thanks for
plus and just get it all?
Yeah. I mean, we just want you using Kepware. So let's start with that. But there are certainly ways of thinking about Kepware that are a little bit different than just grabbing it off of the web and going about your day, although we're happy to have those relationships too. We started to sell contracts for Kepware that are reoccurring every year, and they can contain X number of server installs. They come with a broadened support agreement 24/7 instead of the typical Kepware support. It comes with a cloud-hosted one-to-many configuration and management utility. And it comes with all of the drivers and all of the plugins, all of the features of Kepware, all the stuff we put into Kepware just there. So for companies who are looking to create a strategy around digital transformation, data access is incredibly important. And our view is that you should standardize the practice of data acquisition for these digital transformation efforts as much as possible, to have a single platform to learn, to have a single vendor to be able to support you for this data acquisition, and to be able to invest the time necessary to get this stuff right. The fact of the matter is Kepware has spent 30 years just building protocol collection and data management utilities. So we're implementing, we know the protocols by heart, our developers. We implement as many features of these underlying protocols as we can, as effectively as we can, in order to allow a user or a power user to be able to go in there and adjust not only Modbus block size, but use a couple of different really mature sort of protocol modes with a Logix device. But we also have drivers for oil and gas flow measurement systems and BACnet building automation systems and data centers using SNMP enabled equipment. We could just connect to all of that. And so what it comes down to is sort of, when you're thinking about Kepware, when you're thinking about digital transformation, whether it's one license or one server or 200 servers, there's a thought process that we're seeing our customers go through to say, okay, let me choose my horse for data acquisition. Let me make sure that it can connect to the systems that I need now and into the future, and that it has data egress capabilities for my systems now and into the future. And what we find is a Swiss Army knife of Kepware, the all-in-one kind of just pay per year, a single license ID. It comes with everything. Has been a good way to approach this moment in time. But by and large, again, we just really want people using Kepware out there. Yeah. So,
sure.
Any way you buy it, any license you buy, we're there to help you and there to support.
I'm just imagining the Kepware developer who's just spent the last 10 years of their life thoroughly understanding every protocol that they can, is just the life of the party when someone asks them, what do you do?
Of our parties.
What do you do? What do you do for a living? Tell me more.
Yeah, tell me more. Well, did you know about, DH plus networking across an Ethernet IP network bridged by a Logix 5500? Yeah.
Yeah.
So we eat and
That's
breathe this
usually
stuff.
what I would
And
go with.
yeah, right. Um, Thankfully, PTC parent company provides business training and networking advice. So we've all upped our corporate game a bit. Just joking, but no, it's
Let's
really a pleasure because we to be Kepware, to still be as relevant as we are, if not even more relevant than we were 10 years ago. Um, I can look at the people who write this software, and my team and I help decide the features and functionality and direction, and we work with end users every single day. So I feel like it's one of the only places that the engineering meets the business really, really closely. And there have been some bumps along the way, the past 2 or 3 years, 4 years in particular for us, in terms of you know um, getting products to market as fast as we need to, but in part because of pandemic, in part because of changes in our own strategy. But I think at the end of the day, it's still this product, this place is still a uh, significantly important piece of technology to industrial operations and digital transformation, and in part because we just engineer the heck out of it. I could probably bore you all to death over cocktail party of like our state machines and how they interact with our server core. It's some brilliant stuff. I have to say, it's what other 32-bit platform can move data like Kepware at sub 100 millisecond intervals across hundreds of thousands of data points?
Yeah.
Not even the modern platforms that are coming out today using, XYZ data brokers inside. You can't touch it. The level of determinism that we built into the product, it's really just incredible. So anyway, it's a cool place to be. It's a fun tool to work with, and I'm really glad to be able to solve problems with it.
Let's thank you, Sam. Let's pivot real quick. I want to acknowledge Steve and Todd are asking some OT security questions from an IT perspective. Hey, I'm going to start over. I've inherited this network. What are things I need to think about? I don't want to ignore your questions, guys. I am going to flag them as out of scope, but I also know Alan would love to talk about it. So what I'm going to recommend is that we move those questions to the very end. And then, so guys, if you'll stay on, we'll talk more about that. I promise. Assuming that Alan doesn't have to drop. We've got Kepware in play. We're good. We're ready to start polling. And now as a client, I'm going to subscribe to my Kep server, and I want to start getting data into a historian or to a time series database or to MES. What do I need to, maybe we should start with the time series database side. What
Yeah.
do I need to be
Yeah.
focused on and thinking about? And then as we move to the MES side, Logan, Arthur has brought up some good viewpoints I'm sure you'll want to address and talk to as well. How important is write speed? How important is picking the right database at this point now for a time series historian, for a data historian, for a logger?
It's incredibly important. I mean, deterministic data retention is of the utmost importance in almost every industry, right? Sam, you hit the nail on the head where you said, data is one of the most valuable assets that manufacturers have today because it's one of the biggest things that they can leverage to self-optimize. So making sure that data is in the right place, it's accurate, it's reliable, and it's all timestamped with the right context that you need to actually make decisions off of it is really, really important. And I'm not going to answer the direct question. I'm not going to talk just about time series databases or just relational databases, but I want to talk about the concept of proper database selection in general, right? Because relational databases certainly have their sandbox, right? And they are absolutely necessary in almost every manufacturing organization that you go to, right? Time series databases, I would say the same thing about, because where they really shine is ingest, just as the name says, right? They ingest and produce time series information at a large scale. So their ability to ingest data at extremely high rates with a specific timestamp, all the design that goes in behind a proper and reliable time series historian, so they don't lose performance as volumes go up. All of these things that are incredibly important for a high performance historian. But on the other end as well, relational databases, that's where all your transactional information is going to live. And there's a lot of criteria that go into one, designing properly, but two, selecting the right relational architecture as well. And all of that comes into play when you're bringing all of this together for, let's say, an advanced analytics application where you need context from your master data, which is largely going to be in relational information, but also context from your production runs over the last 6 months, which is process variables stored in time series historians, right? With all of that stuff available, depending on the rate at which you need to make decisions on that information, that's when these considerations, these design considerations become, critical to the success of the longevity of your applications. So
it's a great point, Logan, because at the end of the day, if you're going to try to bring out some type of an insight, um, filtering or slicing your time series data based on a transaction record in a SQL database, and that SQL database is now to a point where it's taking 45 seconds for a query to run or 5 minutes for a query to run and return. How are you ever going to build this insight back into a control loop that where time
yeah,
is important, right?
yeah, and you're absolutely not if you start to hit those speeds, right? Not, I mean, unless you have really, really long decision-making times allotted for the process. But and you get into situations where you're trying to deploy some machine learning algorithm, right? And you want to make decisions. Let's maybe consider like a secondary prevention system for some event occurrence, right? You already have a primary, health safety prevention system in place. That's at your real-time system, but you have this other system that you want to put on to help prevent those even earlier. Where you could be talking, you need reaction times in sub-second, maybe north of 500 milliseconds sort of time frame. Well, having that data go all the way up to your centralized time series historian, analyzed up there, and then come all the way back down is probably not the appropriate architecture. So selecting the appropriate architecture for that situation is really important, right? Where you start to deploy these edge platforms that can make decisions for you much closer to the source of where it needs to be consumed or produced. So,
and really, from my time series background, the number of architectures that we would run into where they were relying on the historian to then push data up to a cloud or to a centralized data warehouse or part of just of their enterprise data strategy. Sam, I don't know that a lot of people are even thinking, why would I do that from the historian? Why wouldn't I just potentially do that from Kepware?
Sure. From the you're talking about confirmation perspective?
No, just for dual logging, right? Like if I'm a lot of times, if you're going to do edge data storage for edge applications, but you also want to centralize data to part of your enterprise data strategy, often you would see double lifting on that edge database, which then requires that edge database to be a bit more beastly, a bit more performant.
Yeah. Yeah.
Whereas I feel like Kepware could handle this in stride if we moved that fork or that duplication of a data stream a little earlier in that process.
Yeah, certainly. To be candid though, we do, if we're landing data in a database, one of the questions that my team asks is, okay, if you have to get data elsewhere, do you already have strategies of database replication? Do you have XYZ? And is that a normal practice for you to use? And there are varying answers to that. But the other side of the coin is that you're absolutely right, Jeff. We spend a lot of time duplicating our streams, whether it's sending to 2 databases or 20 databases, 10 or this and 10 or that, or if it's MQTT or HTTP output here, OPC output here, and a database output here, there's a lot of duplication of that at the Kepware layer. And that's one of the utilities of the Kepware product, being able to do these kinds of data distribution tasks simultaneously and reliably.
Yeah, I have a point here. So when you're looking at databases and where this data is traveling in the use case, edge and data science analytics are different use cases. So when you're looking at an on-prem edge application, as Jeff was talking about, your selection criteria and performance requirements, the hardware you're deploying is different than your pipelines up to cloud and long-term storage, Delta Lake data warehousing, et cetera. So those are different considerations, and you should be treating them separately in terms of an architecture. And a lot of times, I've seen exactly what was described here is you have dual publish streams. So at your event that happens out of Kepware, for example, or as close to the PLC as possible, you send to an edge-driven system or application like time series database for on-prem, And at the same time, you use that event to warehouse to cloud, et cetera. So you're able to treat those streams with the diligence that they require for their respective application.
Ideally, you're also asking the question, and I think Arthur's alluding to it, of what is the true resolution or shape of data that I need at level 4, level 5? Certainly, there are many use cases where you're going to want everything, but there's also the majority of use cases where you don't need everything. And if you're keeping certain things at edge, you can certainly consider pre-processing, cleansing, and aggregating data before potentially moving it up to level 4, level 5.
Yeah.
There, it's the higher up the traditional pyramid we go, the lower the resolution tends to matter to the audience. Right. On the
Yes.
plant side, we're trying to win the hour, win the shift, win the day. We're trying to win the year and the quarter at the enterprise.
Yep.
Sam, are you ready to flip the switch and
Yeah. So one of the things that I spent a lot of time doing is manufacturing execution systems that are involved in process control. So there are a lot of companies out there who just use manufacturing execution as more of a back end or a front end visual system with management capabilities, and it's storing data in the back end and representing that. But a lot of MES systems are also bidirectionally interacting with the process control plant floor. And I'm not sure how many of the audience know that, but it's one of the most fascinating things that I can spend my time doing is tuning the MES to plant floor type of interaction. A lot of this has to do with, say, the types of interfaces that are used between the MES system and the plant floor. They all open themselves up to different tuning opportunities and potential pitfalls or slowness. But the fact of the matter is that the MES layer, the data acquisition layer, oftentimes, at least, if not directly control the next step of the operation, it at least has to provide confirmation that critical data has been stored. And the most deterministic way to do that, especially if the automation system has ephemeral data associated with it, where values would be rewritten, is to send an indication back down to the floor that the data has been collected. So what I've done is build on that time spent, that expertise, to build a demonstration system where I've got some efficiencies from plant floor to middleware, and I've got some efficiencies from middleware to time series database where this is getting stored. And I've got some efficiencies on moving indication that everything has been collected, okay, back down to the plant floor system that generated the information. But what we'll do is look at the destination of the data. We'll then look at the middleware and how it's architected, along with discuss how the information is getting to the middleware in the first place. And what I'll be able to show you is the delta between the information coming out of the process and then the feedback loop designed to go back down to the process to confirm the data is there. So first thing that I'll do is share my screen, which should be the awesome. Okay. Which should be my chosen time series database. So I've got Timebase, a free time series database. It just hit the market. Jeff may know a thing or two about it. But it's lightweight, easy to use, simple to install, really performant. I think I was pulling 100K JSON structures out of this thing every 20 milliseconds. Like it's fast. So anyway, this is my chosen data destination. And for me, this is also this plus a utility that I wrote myself. You can imagine it's almost like a data collection a la MES, delivering some confirmations back down to the plant floor. So I have a simulated bottling line that's providing KPIs like bottle count, glue temperature, other various kinds of things that you'd use or that a process would spit out in terms of a filling system and packing and labeling system. At the end of a batch, the device that I've created produces a batch record, and that batch record is critical. It's filled with really important information that isn't necessarily available from continually querying the KPIs of the system. And we need to get that batch record into the data destination with feedback back down to the device to make sure that the device knows collection worked so that it permits another batch to be run. Otherwise, automation system's not doing anything. The data is that critical. And this has analogs in torque measurements for automotive vendors. They have to legally store different measurements, different types of information, whether they're going to look at it right now or not. So we've been building these types of systems since Kepware was born in the 90s. Now, a lot of those systems, the data itself is critical, but the use cases are questioned. So we still use these feedback loops, not for government regulated data, but just if it's not part of an automated system and important part of the process, just ensuring you're collecting as much as you possibly can is oftentimes a worthy goal and worthy of some interlocks with the system who are producing the data. But that this is more practical use case. My batch changeover is not going to work unless the automation system knows the data's been collected. So that's the system that I've had to architect. So obviously, I want to use that automation system and run it as much as possible and as fast as possible. And that batch handover is not going to happen until that feedback loop comes back. So I need that feedback loop to be really tight, really tight. So it starts with, how do we get the data from the device that's producing it? So I have this imagined bottling plant. I've got a logic controller that has KPIs I'm measuring, and I have a data aggregation PLC that's connected to some other systems, plus the other controller. And then it's the one responsible for creating this really important mission critical batch record that I'm gonna transit through the system in order to build some determinism in there. So first off, I have a simulated data PLC. The PLC is simulated with Kepware. So Kepware has a lot of different kinds of features and functionalities. One of the things that we can do is build a driver that can push information as if it were a Siemens device. And on the other side of that, we can build a driver that catches that information as if it were a Siemens device. And we can do this for Modbus, we can do this for Allen Bradley, there's a few others as well. But our drivers are acting like PLC data servers, for example. So PLCs can query us and read information out of Kepware, or PLCs can write information to Kepware. SIP data table writes if it's Logix, or put gets if it's Siemens, or Modbus function code, 4, 3, or 5, 6, whatever the write operations are in Modbus, that kind of stuff. So the middleware here has been very carefully designed, configured, let's say, with the PLC in order for the middleware to have an event-driven data collection with this data aggregator. And we're not using MQTT, we don't need to use UA, we're using good old proprietary, old legacy standards with Siemens that just happen to be lightning speed and just the right tool for the job. We have other kinds of more, sophisticated, more modern device drivers that tie in with Siemens, but this one is effectively Siemens' version of Modbus that they created 30 years ago that we're using as bulk data movement from device to collection, to middleware collection system, right? So over Ethernet, my PLC, when it gets to a certain point, is going to push a message to me. So if I wanted to, I could look at this value that I'm getting pushed with the built-in little test utility in Quick Client, or in Kepware. So this is an OPC client tying into the OPC interface of the Kepware communications platform. And what you see is that every 10 seconds, a new batch record's created. And my job is to, after I get that published to me from the PLC, as quick as I can, turn around and write that back down to the PLC. So I've done a couple of really important things here in building out this middleware system. Number one, I went into my Siemens device and I added a function block that pushes the information that I want up to Kepware. And guess what the information is? It's a bunch of packed bytes. It's a character array. So all of the stuff that I want, I've accumulated over that 10-second period, and I've built as one giant message, boom. So it can use one transaction to write that information to Kepware. I don't have to query it at Kepware, down to the PLC. That happens a lot. I'm just sitting back waiting, saying, hey, whenever you're ready, PLC, let me know. And 50% of the round trip time of acquiring that from the PLC goes away. Just write it to me, no problem. Just like you publish an MQTT message, it's publishing a Siemens proprietary message to me. So I'm picking that up. And then Timebase has an OPC UA connector. And the connector's done a really smart thing. The connector uses a subscription interface with its target data items. So I've configured the Timebase OPC UA connector to query Kepware. But the way that it queries Kepware is to say, hey, Kepware, these are the variables that I want you to sample. I want you to sample them every 100 milliseconds. And when they change, I don't want to have to ask you again, but when they change, I want you to tell me. And here's the metadata that I want associated with that. So that's what a UA subscription really entails. It's setting up a relationship between UA client and UA server. So UA client doesn't have to do as much. It just catches the information that's sampled or gathered. So now that that's set up, I have some semblance of a completely unsolicited event-driven architecture, not only from the device, but from the middleware too. And that's wonderful. If you can use an interface standard that presents an unsolicited interface or subscription interface or a publish interface, then do it, because you don't want to have to continually query the middleware, just like you don't want to have to continually query the automation system if you can help it. A lot of the times, the work that I did on that Siemens PLC, you can't go and retroactively add function blocks to a device that's already running. I get it. You treat it as a data server and you do the best you can to use small numbers of requests, gather as much as you can at the same time, fail quickly, retry fast, all those little techniques that we've used for years to sample at very rapid intervals. We just have to employ. We can't have an event-driven architecture from PLC up. So we have immense tooling and expertise there, but if we can try to make it event-driven across the board. I will spike for a minute and say data servers are great, because if you want to make a change into what data is presented to you, the client can say, hey, I don't want that anymore. I want this one. If you do an event-driven architecture, whether it's a proprietary push from Siemens or if it's a MQTT push, you got to go in there and recode what you're pulling. That is a downside. So use event-driven where it makes sense. It usually makes a lot of sense as a general rule of thumb if the system can be changed, if the data types of data requests are not dynamic, and you just have a fixed set of information you want to publish at an interval. That's great. Anyway, long story short, there are going to be some inefficiencies you'll see in the system. So I'll go into the middleware that is Kepware and show you the round trip that's coming back after the data is made available, and then we'll see that there's a time delta in that, and it's not a huge delta, but this type of time delta, believe it or not, was enough. 600 milliseconds was enough to fly me out to Kentucky to do consulting for a week with one of our major customers, where their homegrown MES needed to interlock with the plant floor, and it was a 2-second cycle time when they were shooting for 900 milliseconds. So this stuff really matters when it comes down to it in certain scenarios, and you just can't pass go without these kinds of checks and balances. And so anyway, long story short, the data is now arriving into Timebase, and you can see it here. And I have an application I've written in Python that acts like scripting against the MES, right? So what this is doing is reading the MES's REST API. It's pulling in my batch run. If my batch run is new, this script blindly assumes it's a good batch run. There'd be some integrity checks or something in real life, but this script blindly assumes it's new, and it pushes its back down to Kepware using OPC UA. So I'm reading REST APIs with this script, and then I'm writing OPC UA with this script. And then down through Kepware, the information is going to transit back to the PLC. And the PLC says, that is the record I sent. The variables are equal. I know you've got it. And then I can move on to the next step in the process. So whether it's a Boolean indication of true false that comes back from the collection system, or if it's actually the information or a subset of information, like a record getting pushed back to the PLC, letting the automation system look for itself at the data that it sent and the data that it thinks it should be there, and then doing a comparison, that is wonderfully deterministic. And you're able to guarantee at the automation side that the data has been collected. So very safe. Anyway, once I get this going, I'll go ahead and start this. And you can see I've pushed my first batch record down, and this should cycle every 10 seconds. So now my system is up and running. I've got KPIs being gathered into Timebase, and then I've got Timebase also collecting that batch record every 10 seconds with my Python utility, confirming the data is there, shoving it back down to the PLC, and then letting the automation system confirm it's there too. So if I jump into my middleware, I'm going to show you diagnostics from the Kepware system. So this design in Kepware uses 2 independent connections to that same PLC. One connection is a passive listener where the PLC writes information, and one is an active client where I'm going to write information back down to it. So I've tried to name these objects in Kepware simple. Batch from PLC is the listener.
Sam, we lost your audio. Oh, we lost Sam.
Come on, Sam. Did we lose them all
About
together?
15-second response time last time. So, oh, he's back.
I'm back. Yeah, I think, unfortunately, I think our network are having problems due to the snowstorm up here.
You're fine. So we heard you
Sorry,
say
audience.
you were you named confirm, I think.
Yeah.
to PLC.
Yeah.
Yep.
Yeah. So confirm. So this is me pushing the record. This interface right here is receiving the batch record from the PLC. And then this is a confirmation back, a protocol level confirmation back per Siemens protocol design that yes, command succeeded. I am not denying the command. So the PLC knows that its write operation succeeded because Kepware told it did. And then Kepware turns around, passes that information up over UA. My Python app pulls it out of Timebase, shoves it back down to Kepware. So the shoving it back down to Kepware is visible in this diagnostics interface. And so now I have two diagnostics interfaces available to you guys. One is showing the messages from the PLC that are being caught, and the other one is showing the write operation moving back down. So you can see a couple of things here. So I have a timestamp of message receipt of 17 seconds, 669 pass. Now 7:30 after 27. And look at this, I've got 18.274. So you can see I've got over 500 milliseconds of dead time there. I can see the time that I caught the message. I could also dig into OPC diagnostics out of Kepware and show you the message actually leaving Kepware too, and the timestamp associated with it, which would give you the internal processing time of Kepware. But to respect the time that we have and the fact you all are looking at this over, tiny little things changing over a screen, I'll spare everybody. But long story short, this is the delta between transmit and response of really the whole system, the whole round trip of the system. You can see there's only maybe a millisecond to move messages back and forth across my internal network here. So dead time in the PLC is not a thing. It's everything else above that is taking some time. So at this point, we would talk with the customer and say, okay, it looks like you're getting a cycle time of roughly 600 milliseconds. Is that good enough? And they might say, no, we've really got to cut that down to 300 milliseconds. And so then we're thinking, okay, we're already publishing from PLC. We're already subscribing UA. What are the other pieces that can speed things up or create bottlenecks? So one of the bottlenecks that can be created is the time that Timebase is actually sampling. So I don't have to limit to 100 milliseconds. I could actually go down to 10. And that might shave a millisecond or two off of the UA transit from Kepware to Timebase. And because the driver here is just catching the information, that 10 millisecond sample is not going to send a broadcast out the network and query that PLC. The threads that are going to be running at 10 milliseconds are just hitting server core, and then driver is always looking at that set of messages every 10 milliseconds regardless. So the interface threads are really just checking cache every 10 milliseconds given the setup here. So really no harm, no foul to dial up the rate that that client is requesting. The other area of potential performance improvement, you see 600 milliseconds is quite a bit when you look at the zero amount of time that the diagnostics are showing the information arriving from the PLC, right? So where is that time being spent? And just like when I flew to Kentucky, it turned out that the homegrown application that the customer had been building, very sophisticated homegrown app, but it was using a database query that had a 1.5 second query time. To Jeff's point, the table size was really large, and they hadn't used the right set of functions in their query to get around that fact. So once we figured that out, they were able to modify their query. They cut at least half of that 1.5 seconds out, and we got within the time frame. But my application is not optimized. I could look at some diagnostics here, but I could show you that it's probably 300 to 400 milliseconds of cycle time that I'm spending just within this poorly designed Python app to consume things as fast as I can out of the REST APIs from Timebase and then push them back down to Kepware. So two things that I could do differently inside of my application here that is really pulling information and moving it back down. It is, number one, this time series historian has a WebSocket interface. So right now I'm using its REST API and continually querying, and that's taking time, and it's loading the Timebase with some work to do. I could re-architect this app and just set up a listener for that WebSocket, just like UA. I could UAify or subscriptionify my data pulls out of the time series database by using WebSockets, a bidirectional sort of layer above TCP. That's option one. Option two would be I'm only issuing write operations from this UA app over to Kepware. But the way that I'm doing that, I'm connecting to Kepware, issuing the write, and then disconnecting again. And that incurs a penalty. Every time you connect to Kepware and load an item to write, we've got to load the item in memory, do a bunch of little things. And it might take 2 operating system cycles in Windows to do that. So maybe like 30, 40 milliseconds of just setup time. And then we issue the write operation, which usually transits pretty fast, 10 milliseconds through the guts of Kepware. But you can see if you don't have to load the item every time, you're going to save 30, 40 milliseconds. And when we're really looking at that type of cycle time, trying to get things in under half a second, every drop of speed matters. So we might look at using different UA commands or UA functions that as soon as the app starts, it sets up a relationship with Kepware and maintains that relationship. And that is a much less resource intensive thing to do than just continually spontaneously deliver write operations to a UA server or really any data server. If the protocol you're using with that data server allows you to give that server an indication of who you are and what you're about to do, then it'll take less time to actually do that work. And what that means in UA is registering your nodes prior to taking action on them, which I could be doing in this app. So between adding a WebSocket, basically subscription interface to Timebase, and then maintaining and managing my connection to the UA server a little bit better, I could probably get about 200 to 300 milliseconds of savings there and cut down that cycle time from roughly 600 milliseconds to 200 or 300 milliseconds. And believe it or not, when we're talking real MES deployments, this type of stuff, it's all on premise. The hybrid MESs, we're not allowing or suggesting people do this. We're always using, even in hybrid MES where some of it's in the cloud, there's always an edge component, or usually if it's GE, if it's a big platform, there's some presence on site that this scripting and this work is happening. And then the delivery timeframes, we're working with them, the designers of those script routines, to make sure they're as efficient as we possibly can. So anyway, that's what I wanted to show you all. The really, what the rubber hits the road is, what's the difference between how much time is it taking to get the data from the device, transit through Kepware, send it to the destination, and then confirm it back to the process so that we have a deterministic relationship of data acquisition. And you can see then in this particular scenario, I've got a few different areas of improvement. The PLC side looks really good. I'm publishing from the PLC. I don't have to query. The published side from Kepware looks really good. I'm publishing from Kepware. I don't have to query. But the pieces in between, the scripting in the database, the scripting in the MES, that's where my slowness in this scenario can come from, along with a little bit of UA setup that could be done. So I think I'll stop there and let anybody on the panel or customers ask questions.
Awesome. Sam, as we are waiting for questions to come in and handling some that have already come in, I want to just say to the audience, Kepware has a series of resources they're happy to make available to you. I'm going to throw up a poll, 2 questions on the poll. First is, if you'd like some of the guidelines, benchmarking guidelines, and resources Kepware has to help you in this effort, throw a yes. And we'll make sure that someone from Kepware gets you that. And then second question, we've got a conference in 2 weeks called Prove It going on in Dallas. Are you going to be at it? I'd love to know in advance who's going to be there. Maybe we can do some type of a meetup. It'd be a lot of fun to get maybe grab a lunch all together, sit down and have a conversation, see what the other half of our bodies look like. Cool. Thanks for taking that poll. And wow, looks like a good percentage of the group that's on here actually will get to run into each other at Prove It.
Those of you that will be at Florida at S4 during that same week, you can hit me up.
Alan will not be at Prove It. Shame.
I won't be. I'll be at the S4 events.
Oh, and I dropped a link for Timebase in the chat. If anyone would like to download Timebase, it is a completely license-free, use it as you'd like time series historian that is out there for you to enjoy and take and do with as you please. Timebase.com for that. All right, we have some questions coming in. Drop them into the Q&A. I'm going to come back. Remember, we're going to do the security one last. Jacob, question for you. Any good experiences with real-time near microservices for instant directly on sockets? supporting the more heavy data flow in and out of databases?
Yeah, so I mean, when you're looking at protocols over TCP/IP or UDP, it's all about the binary frame and overhead associated with that binary frame. So that's why these, native drivers and protocols are so much leaner because you're actually transacting a fewer number of bits on the cable. So socket is, super performant in most cases because you are constructing the schema behind the binary that comes across, and it truly is up to you to make it as lean as you want. Um, of course, as you move into different protocols, REST APIs, OPC UA, MQTT, et cetera, all those have additional overhead on the protocol to provide functionality, like acknowledgement functionality or organizational modeling functionality, et cetera. So I would say, long story short, if you want high performance, always look at socket, potentially construct your own binary format in a socket for representing that data. What you're doing when you do that is creating a proprietary protocol yourself, in essence, which is kind of funny, but that's the best way to get information out. Now, the trade-off to that is the more context you want and meta information associated with that transfer, real-time transfer, that adds overhead to the packet. So that, that you have to have a balance there. So yeah, that's my answer to that.
That's a
Awesome.
great answer, Jacob. Yeah.
I'm just scrolling the questions. Let's see what else is sitting here. Use case of collecting 100 plus remote stations to a centralized enterprise SCADA application in near time. What could be the few points we should start with sketching out the Kepware architecture for this?
Yeah, it's a great question. I have a unreleased guide I can send to you, Siram. The simple thing is check the languages you need to use to talk to your equipment. Check if any of the equipment can be reprogrammed to publish information up to Kepware. If it's static information and it's not going to be changing, can you do event-driven collects, from your process equipment? Does Kepware have the driver for that? And do your devices speak the languages of those that we have? If we're going to be soliciting information from the devices for data acquisition, then it becomes how to configure Kepware for, but not to create inherent bottlenecks. So yes, definitely separating devices into these objects here. We call these objects channels, and channels are state machines, an instance of a driver. You can create many, potentially hundreds, even thousands of instances of one or more drivers inside of a single Kepware project. And when you create one device per channel, you're really dedicating a driver instance to that one piece of equipment, which is fantastic for performance. But if you're then going through a shared medium, many protocols hitting a cell tower, for example, depending on how far in the infrastructure for those remote stations, the one device per channel, the parallelized communications across that medium, you might not have bandwidth to support that. So your latency spikes incredibly large, right? So then it becomes about designing a happy medium between how much can I do at a given point in time, so as not to exhaust the intermediary hops that need to occur between centralized SCADA and then the remote RTUs. And packet sizes, retry behavior, all kinds of stuff come into play. A lot of that, as I mentioned, sort of, a lot of that's baked into the protocol drivers. For example, this PDU size, this is a protocol data unit. And this is a feature of Siemens that allows, potentially multiple packets to be glommed together into a single larger 960 byte frame. Well, these 960 byte packets might be too large for a bandwidth constricted medium. Maybe it creates too much latency because of the limited bandwidth available. So we might decide to break that down into much smaller pieces and just move a message with less surface area. Maybe that plays better with the network. Other times we might try to retry faster. We might, if it's a known problem device, we might employ a feature that we built in called auto demotion, which just arbitrarily stops the device driver from talking to that one device for a while. So if you do have to create, for bandwidth reasons, usually these days, multiple devices below a channel, you don't have to spend all of your retry times, trying and failing with this one device when that driver could move on to the next device in the channel. So there's a bunch of different techniques, and it kind of, again, starts with, can I be event-driven? How do I bring event-drivenness into this architecture? But I may not be able to be event-driven everywhere if the needs of that SCADA are dynamic. And what a lot of times happens is as you're moving across SCADA screens, the data sets that those screens are requesting, they're actually loading and unloading the data servers, the intermediate data servers with those. And so depending on your SCADA system, it just might be a fact of life that the event-driven stuff just won't play well with it. But ideally, we could try to have the PLCs push to us or the systems push to us. And if we can't, there's a lot of different kinds of tuning we could come to employ.
Maybe if I can add one thing to that, and maybe ask a follow-up question to Sam as well for my own information, and hopefully for the audience as well. But protocols like MQTT, right, where you can do specified batch times, where you're not transmitting information every single time a value changes, even though it's report by exception. You batch over, let's say 5 seconds. So every 5 seconds, you're sending every tag change up with their timestamps up to your centralized SCADA. I'm not personally familiar. I have never used or deployed the MQTT protocol or the module for Kepware, but I would imagine the same settings apply within Kepware as well, where you can set your batch time. That way, if you are just reporting or trending this data points, everything's going to come through every 5 seconds, but it's going to have the timestamps for every change that occurred within that 5-second time period as well. So you can get all the information with less frequency of transmission.
Yep, exactly. So exactly, buffer and send is a thing, whether it's HTTP for us or if it's MQTT or database insertion. All of those utilities inside of Kepware have this capacity to say, all right, if I can't move things out fast enough, how do I build up and then move things out more slowly? And I wanted to say that that company who had all those issues with interlocks and delivery to the plant floor, their second generation of their architecture used REST APIs. They treated Kepware like a REST API. So we have, for every implementation we do with them, they turn on our HTTP publisher called our REST client, and they have a server-side API in their MES, and they just catch information delivered to us, delivered to them. One of those things is an indication of, it's a true indication that the automation system is ready for a data collect. They can't push information to Kepware, so they have to have us pull. So what we've done there, they need to guarantee that they're pulling data from the plant floor, not from the middleware. They can't tolerate potential cache reads from Kepware. So in addition to publishing the presence of this trigger to them that says data is ready, we stand up a HTTP server in Kepware and become a REST API for reading and writing. And one of the things that we can do with our REST API is tell this system, do I read from cache or do I trigger a driver read, which is basic OPC DA like 1.0 feature set that a lot of automation systems come to rely on. So again, just as a publish subscribe system built with Kepware, just using REST APIs, rebuilding a lot of that technology that OPC UA adds or DA adds. But in this case, this customer had never built an OPC UA interface. It took them a while to build an OPC DA interface. APIs all over the place. So they were like, wait a minute, we can treat Kepware just as a set of APIs? Fantastic, let's just do that. But it ends up being a little bit more configuration within Kepware to get that done, but still respecting the publish and then set up a server API with rich features for articulating the plant floor in the way you need it.
Yeah, I wanted to, Sam had a really important piece in his presentation that I've learned is super important is we talk about high speed bandwidth data, and we talk about requirements for that data and landing and tech requirements or whatever. When you're trying to validate against those requirements, the observability into your actual performance is super important. And a lot of utilities and tools either don't have that option of observability or the ease of observability. So you really need to be planning for observability into your systems, outside the context of just meeting a tech requirement, because you have to validate against that requirement. So planning for that in the future. And of course, you saw Kepware has those, observability features built into the software becomes super important.
Yeah. Thanks, Jacob. That's great. Yep. Other types of tools that we'll use to monitor this stuff. We use Ethernet packet capture tools a lot, serial packet capture systems a lot too. We typically use a dissector and a packet capture utility baked all in one. It's called Wireshark. popular with IT, popular with OT, tons of different dissectors that are built by vendors or community. So it's easy to untangle a lot of the more difficult proprietary, especially proprietary ones with Wireshark. But NetSH on Windows, built in, Linux, same idea. Ethernet packet capture is just your friend when it comes to proving the speed and all kinds of different types of data movement scenarios. So as much as I'm showing you the baked in, diagnostic views of these things today, inside of Kepware, I want you to know that one of the key tools in our toolbox that we oftentimes pull out even before the baked in diagnostics of Kepware is just Ethernet packet capture with Wireshark. So we've got guides available, more applied usage for Kepware. We've got some blogs we've written about it, but that's one of my favorite tools in my industrial automation systems integration toolbox.
Alan, Alan, just assume, if you would, try to put on a hypothetical here, and assume that you have inherited an OT network and you wanted to start over with OT security as your top issue. What would you do?
Well, the very first thing you have to do is you have to create a standard. You have to know what you're working towards. And so you got to create a standard and you got to create your policies. But once you have that kind of nailed down and hey, based off of, what the appetite of your leadership is, because that's critically important, right? Because you have a NIST maturity for 62443 or NIST 800.02 or whatever. What you have to make sure you're doing is you're working towards the appetite of what your leadership and the company says, hey, this is the level we need to be at, and understand what that is. Once you've got that all nailed down, you got your policy, you got your standards, and you know what the appetite is. We're gonna shoot for a maturity level of 3.0, NIST 3.0. Great. Get all that. Make sure you have that nailed down, because otherwise you will not be in sync with your leadership. Once you have that nailed down and you're going to start over, then make sure that you're putting in security, it's defense, layers of defense, right? You're putting in a proper DMZ. You're putting in and Kepware becomes a very critical tool here, because what we typically do is you put in a process firewall. You might even have a DMZ where you've got a firewall between the IT and the DMZ, and then a firewall between the DMZ and the OT. And we have a tendency as security professionals to have a firewall team that creates rules. So, hey, I've got this system that needs to talk to this ERP system, and I'm going to create a rule that's going to allow that to go through. Well, you just egress and ingress, you continue to make opportunity for vulnerabilities there. So if you can start to think about, can I control the egress and ingress into my zones? And by doing that, I now can have Kepware being kind of the data piece that is making the connections and getting me the data. And then another sponsor of ours, Flow Software, has Data Hub. Well, you could take Data Hub and you can actually, using Data Hub, you can now take any protocol that you can get from Kepware, and then you can change it to a different protocol. You can change to HTTPS, you can change to MQTT, whatever. And now you can have a single secure pipeline between the DMZ and the OT zone. You control that one pipeline, and now you have control of your egress and ingress into those zones. And you can do all kinds of things at that point. And now if you have a true DMZ,
Hey, Alan.
Yeah.
Just real quick, not Flow Software, although I love that we're on the tip of your tongue. Software Toolbox has Data Hub, just for the audience, in case you're.
Yes, thank you. Yeah, and so to that point, here's where I would use Flow Software, right? So now you think about and this is important because you think about your OT legacy equipment, right? And what's the one thing when we start to talk about how are you going to monetize OT data? It's the naming structure, all of that stuff is just the data quality to do it is horrible. So now you have Kepware, you've got potentially Data Hub, or Flow Software even would do this. Flow Software sits at that zone, and now you build your templates in Flow Software. You connect all of your different devices down there, and so you take plant one, it's got a bunch of chemical stuff. You build templates for those chemical or free water knockouts. I've got a bunch of free water knockouts and generators. I build a template for those things. All those tags down below are going to be different. Joe named his ASO1, this guy named his whatever. But once you have that template layer and you control egress and ingress, now I can publish out my templates and now I can do analytics across all of my plants. And guess what? Every single tag is the same name. I can do analytics. The data quality is good. All I got to do is make sure when the technician connects his data to flow, that template, it's accurate, tested, validated, done. Now I can publish all that up. I can get it into a layer 4, layer 5 zone where I can do analytics, machine learning, whatever. But the key for security, if I was building from scratch, I would control my ingress and egress into those zones. I would have a true DMZ that has a kill switch that I could open up if needed and disconnect OT from IT. And once you can control egress and ingress, once you can control the DMZ, now you have a layer of data movement that you can start to do all kinds of stuff, but you don't have to go and create a bunch of firewall rules to get the data moving around.
Alan, I heard you say something years ago where it kind of shifted the mind frame around focusing, of course, focusing to keep bad actors out, but also assuming that they're already in.
Yes.
And from a security level, trying to
Especially
find where those
especially
vulnerabilities are.
if you have a company that has a lot of IP, the bad actors that are in your system are not going to expose themselves because they want to propagate out the IP so they can exploit it.
Right.
So you have to start, that's where in companies like Clarity or Tenable OT, you have to start understanding the patterns of your network, the data movement, the size of data movement, all of those pieces become critical. And the only way you can actually validate that is you have to start to monitor and check for movement of data. You have baselines, you have patterns. Are those
Right.
patterns changing? If they are, somebody needs to be looking at it. So
every 24 hours at 2 a.m., there's a data packet about the same size that goes out, or once every 7 days.
And where's it going? Yeah,
Where's it
exactly.
going? Right.
Yep.
And those, you said two recommendations for someone to look at there was Clarity.
Clarity would be probably my first choice, but Tenable OT, Cyber Vision, there's a lot of OT. And here's the key for OT vulnerability management. You want to have a good active scanning tool that can scan legacy equipment and not bring down your production system. So Clarity does this really well. Tenable OT does this really well. Cyber Vision, they have these what's called light touch scanning. They use the protocol of your known PLCs and OT and equipment, and they will go out and try to do hey, I see you. Can I talk to you? If I can't talk to you, I'm not going to continue to bombard you and lock the thing up and then bring your system down, right? So those, bringing in these IT scanning tools will just cause all kinds of headache for you. So I could go on for hours, but I don't have hours. So
no. And we're outside of scope, but I'm super appreciative of you taking the time to answer that. And thank you to the audience for asking. Sam, I promised everybody they'd hear how Kepware got its name.
Yeah.
You have the 30 seconds.
Yeah.
And we'll sign off.
Can I add like 10 seconds? Stephen Larson had a great question in the Q&A.
Oh, yeah.
Real-time handshaking over Wi-Fi. Yeah, any protocol is fine. Just, imagine Wi-Fi is much more volatile. So if you're designing something on your own, if you want to use UDP, there's no transmission guarantees for that. So you're going to need to do extra checking on your side. Even if you do use TCP, you're still going to want to verify that your bytes, the integrity of your bytes are there. And sometimes they won't be there. So you need to build in, whether it's proprietary or based on some known standard, the ability to make sure that you're accommodating that volatile network medium. And from there, MQTT can be pretty heavy in some ways, can be light if it's well engineered. Proprietary protocols can also be very light or very heavy. And so I would just think about the use case. The protocols matter, I think, a little less than the understanding of what your Wi-Fi network really kinds of amounts to higher latency and potentially more packet loss and lower bandwidth. And so what are you doing on the protocol side just generally to accommodate that? So if you can try to have the device publish something, but then you've got to configure the device to understand if it got there or not. And then if you're transmitting something back over Wi-Fi, same thing. You've got to make sure that it's not just a spray and pray. Depending on how critical the information is, you might end up having to do a little bit more checks and balances. So like within the
And he's gone.
And the snow comes down in Portland. I can only imagine.
I do want to add one thing to that while we're waiting on Sam, is that if you are considering using MQTT for something like that, make sure you consider quality of service as a key consideration, because depending on what QoS you use, with MQTT, it's delivered at least once, delivered at most once, or delivered exactly once, right? So when you're talking handshaking, that's incredibly important to understand.
Yep. Thanks, Logan. Sorry, guys. I thought by coming into the office, I would avoid snow-related internet problems, but so it goes.
I got to jump, but I want to hear the story on Kepware.
Awesome. Yeah. So I think I lost screen share. I was about to say, like, timing settings are important. We bake them into the product. If you're not going to use Kepware, timing settings are important. Go figure out, how to adjust timing to accommodate your network, and then think about protocol. And if you have questions about it, talk to somebody who has worked with a lot of different protocols over a lot of different network mediums. And there are a few systems integrators like they're on today, and a few companies like Kepware who have. Kepware, not a very relevant name for industrial automation, right? A lot of people think it's keepware. Yeah, like I'm keeping my data, but it's not. It is KEP, Kepware. That comes from a little known, well, depending on where you spend your time, maybe not the most prominent company, but a company in New Jersey called KEP. If you wanted to, you could go to www.kep.com, kep.com. I believe that's their website. The KEP initialism means Kessler Ellis Products. The guy named Ellis and a guy named Kessler formed a company back in the 70s or 60s, creating flow measurement devices and some software portions, but really heavy into hardware systems. They had a kid. That kid's name was Corson Ellis, Corky. He took over his parents' business at a certain point, but really understood that software for operations technology was going to be huge. And so his family vacationed in Maine when he was growing up. He fell in love with the community and culture up here. And so when he came of age after working with his parents for a while, he moved his family up to Portland and started a company that he would think took the heritage of Kessler Ellis Products, but understood that we'd focus on software. So Kepware is the name of our company today. So that's the lineage and the history. Corson Ellis, Corky Ellis's dad, KEP, and Corky Kepware to extend the Kep lineage out to software. And now at this point, it's like, Jeff, I think you mentioned it's like Kleenex, which warms my heart. It was a bit like that when I got here 13 years ago, but it's just even become more so. Even as part of PTC, we're still the brand Kepware is still very strong and prominent on its own. So I'm proud of that for us, and I'm also grateful to work with a bunch of people who still write amazing software code and know how to run a business. So
that's awesome. Well, this was a lot of fun. Jacob, Logan, Sam, thank you so much for being here. Sam, I've never seen someone as passionate about the product they work with in my life as you are. And that's hands off. Congratulations. And I just have to figure out how to steal you now from Kepware and flow guy. I'm just joking, Kepware. We love you. We wouldn't do that. Jacob, thank you so much for being here and representing Flexware so well.
Thanks, guys. Really appreciate having me on.
And Dwayne need to buy you a burger. And Logan, I owe you a big old steak dinner in 2 weeks in Dallas. Thanks for being here.
Thanks for having me, guys. Always a pleasure.
Alan, thank you. And until next time, signing off to the community. Thank you for your constant support. And Kepware, thank you for all that you've done to help build this community. Everyone have a great day.
Thank you.
And I hope we see you in Dallas in 2 weeks. Cheers.
Thanks so much, everyone.
Thanks, guys.